Hello all and welcome to the project Determining Red Wine Quality. So now this is basically a primitive machine learning project in which we'll be using different data analysis techniques and pre-processing techniques. Then we'll be doing the project in two ways in the regression and classification reports. So now as written during the course of this project, we will learn about primitive machine learning techniques used in regression and classification. We'll try to do the same problem using two different approaches. That is, we'll be approaching the problem with two different approach and then we'll be observing the results. We'll see in the next section how those approaches will be. So now, what is the motivation behind this? Like, what is why we are doing this project? So basically, this is a more of a practice project to brush up your machine learning skills. So a brief intro about the problem is by knowing the quality of wine, such as the balance, intensity of flavors, complexity of the wine making process, clarity and length of finish. These attributes and our benefits are very important to the market customers. Like these attributes decides if the wine is good or bad. That is what we'll be predicting, and the quality or the basically this correlation is important to many customers, and this can help in a company like in improving our business strategies. Like after seeing the results or observing the data, we can improve our business qualities or standards in observing the change in the making of the wine in the overall development. As I said that we can change the making process like a few components on the basis of review. In catching with the market trends, we can prop different advertisements, we can target different customers, like in serving the customers in a better way. Like we can target different customers of age group, how to target. We can do all of those things by checking or by doing some data analysis. So now, in as I said, we'll be performing some EDA. So the basic questions like what we can do with a data set. Okay, this is a data set which contains several important things like the chemical composition of the wine, like the alcohol content and the different sulfide content, all different things present. So we can find out that what is the most important ingredient, what is the scale of quality, like how the quality of the wine is distributed in what scale. We can say that, and we can find out the correlation between the ingredients, like which is the most important ingredient, how are they independent. Like if we add something, then will it affect the another one? So we can see that using correlation matrix. Now the problem statement is like that we have a data set which is having certain parameters. Basically we have our independent variables, then we have a dependent variable called quality. Okay, so now we'll on the base of that we'll be trying to predict the quality of the wine. Okay, if this is the content of the wine, okay, I can tell you if this will be the wine a good or bad. If you are not a wine taster, you can obviously tell it with these criteria. So the main part of this project is we'll be doing this in two different approach or two different methods. The first method will be directly predicting the label encoded quality of wine. Suppose in the data set it is giving the quality of wine is 1, 2, 3. Like in a scale of 1 to 5 it is given. So we'll be directly predicting those scales and we'll observing the accuracy. Then in the next thing what we'll do, we'll try to benchmark the results. Let's say if the wine is greater than this quantity, then it is a good wine. Then we'll try to classify the wine into good or bad. Then we'll observe the accuracy of our results. So these are the two different approaches. Moving on to the basic timeline, so it is the same. The we'll first will be importing libraries, then we'll be performing data analysis, then we'll be predicting with labels like I have told you earlier, then we'll be classifying on the base of good and bad. So let's begin and move on to the notebook. And welcome to the notebook section of our project. So now in the introduction section, we have seen a glimpse of what we'll be doing in the project. We have discussed that what will be the two approaches we'll be using. So now as written in this project, we'll be using machine learning to determine the quality of red wine with the help of factors like chemical composition of the wine, like the content of sulfur, alcohol, and the quality of wine. Okay, quality of wine is a dependent variable. So the timeline is the same. Importing, first we'll import libraries, then data analysis, then data pre-processing, then our two methods, prediction with using KNN and then classification using SVM. So now the first thing is the libraries which we'll be using will be NumPy, Pandas. These are you have known these are for pre-processing or data analysis. Okay, data analysis, and Matplotlib and Seaborn are for basically visualization. These are for visualization, and this line basically keeps your figure in this notebook only. Okay, now we have standard scaler, train test plate and standard scaler. So I'll just remove this from here. This is for pre-processing. Okay, this is for pre-processing. This will be the right thing to say, pre-processing, because we'll be processing our data, we'll be splitting our data, then finally we have something called confusion matrix and accuracy score. So this is for evaluation. Okay, so now, and there will be certain libraries for our models which will be importing that time only. So now let us read our data set. Okay, I'll just let us read our data set. And what we have here is, you see, now we have certain independent variables, and dependent variable is our quality. So now, as you can see, these are variables like fixed acidity, volatile acidity, citric acid, like what is the amount of citric acid present in wine, what is the amount of alcohol present, what is the pH of the wine, the density of the wine, what is the total sulfur dioxide present, free sulfur dioxide present. So all of these are basically the chemical compositions. Okay, and this is the quality. So if you want to see what is the quality, like how many, what is the scale of quality, we'll just write df quality dot value counts. So as you can see, this are a level of 1, 2, 3, 4, 5, 6. 6 level of quality starting from 3 to 8. Basically, we can see that this is pretty much of a kind of unbalanced data set, because most of the values are between 7, 6 and 5. And obviously the low quality is also less and the highest quality is also less. 5, 6 and 7 are the most abundant, because obviously that is the average quality of the wine. So we have had a brief intro about our data set. So now in the next thing, in the next section, what we'll be doing the data analysis part. Okay, we'll be observing this data. Hello and welcome to the next section of our project. So now in this section we'll be doing the data analysis. So we have seen our data set. This is our data set in which we have this scale of quality. So now let us see the statistical meaning of our data set, like what is the count. Basically there are around 1599, around 1600 rows, like the 1600 data we have. This is a pretty short data set. Then the mean of fixed density, this, and the mean of alcohol present is 10, like approximately 10, what will be the unit, whatever the unit is, that much of alcohol is present in all the wine. The average pH is 3.3, and the maximum pH is 4, and the maximum amount of alcohol present is 14.9, approximately 15. We have mean, we have standard deviation. Then let's just see the basically the type of our variables. So all are float, only the one integer is variable, because it is in form of range 5, 4, 3, 2, like that. So let us see if we have any null values. I'll write here, this is for checking null values. So hopefully we have no null values. That is a very good thing. So finally, let us see the shape. We have already seen 1599, the total count. Okay, and total of 12 columns with 11 independent, and 12th one is our basically the quality. So now let us plot the histogram for all the variable, like all of them are continuous variables. So let us see the distribution. For that, I'll just write df.column. I'll just list all the columns here, and I'll just say df.hist. So it will plot all the columns, as you can see. So the fixed acidity, the most of the column is between 6 to 10. Then we have volatile acid, most of the value is between 0.25 to 0.7. Citric acid is a bit distributed. Now as you can see, residual stool is rightly skewed. Free sulfur dioxide is also skewed. Only pH density is normally distributed. Also some of the sulfate also. Rest of all alcohol, total sulfur oxide, volatile acid, these are all skewed. Okay, either negatively or positively skewed. Okay, and this is the quality. As we have seen that 5, 6 are abundant, then followed by 7, then the least are 4, 3 and 8. Okay, so this is the visualization. You can change the color also if you want. You can write here red, Okay, and the default color will be blue if you'll not write, if you'll not write anything, and you can also change, you can just left, does not need to mention the color, so the default color will be there. And then we'll plot the box plot. So what we'll do, we'll just uh, try a loop for call in calls. The calls is my this column. So for each column plot a figure, then plot a box plot, and then plot the title for that call. So let us see the box plot. So this is basically our box plot. And these are basically our outliers. Okay, fixed acidity outliers. Outliers are basically someone the data points which are residing out of your 100 percentile of the data. So there are very less outliers. Only in residual sugar we have some, and chlorides, then free sulfur dioxide, to TSD, density, pH. If you want, you can also remove these outliers by limiting your data to these values. But our data is very short, so it will only help take in the loss of data. So we'll actually remove, or we'll not do that in order to not compromise our data, because we have a very small data set. So let us find out some relations between some data, the scatter plot. So we'll be finding out first between the density and the pH. Okay, density and pH, a very simple code, plt.scatter, the label, then show. Okay, so as you can see, there is no much correlation. If it is pH and density, there's no much relation that we can see. But okay, we can see that density, the less density means higher pH, and more density means low pH. A little bit of correlation is there. Then fixed acidity and volatile acidity. Okay, so as you can see, it is almostly the same of the, if the fixed acidity and volatile acidity find in the same domain. Okay, because the acidity is the same thing, fixed or volatile, no matter. Then we have free sulfur dioxide, total sulfur dioxide, the same thing. Okay, the same thing, but total and free, there's not much difference between them, so all of them are residing in one place. So also let us see a little bit of correlation. As I said, that what is the correlation, or basically the pair plot. Okay, sorry, what I have done, okay, I have done a blunder. I'll just write sns dot pair plot here. Okay, this will be a very bad plot, I think, because I have plot given the correlation to the pair plot. I have to give that to heat map actually. So let us wait for this till it will get executed. Till that, let us write our code for a pair plot. SNS, sorry, heat map, sns dot heat map, and we'll just write df dot core. We'll pass this first, it will get executed. So this is wrong. Okay, we have to give the pair plot for this. If in this you can write hue is equals to quality, this will work good. Okay, this will, so it will give me the insights based on the quality. Okay, but here it is taking too much time. It should get executed by now. It's taking too much time just because we passed the wrong parameters, right? Okay, this is meaningless plot. Okay, this is, I don't know what this is, so I have passed the wrong parameters. Okay, this is my heat map. So as you can see, the correlation between quality, the most correlated one is the alcohol. And then I'll just write here anode is equals to true, so it will just pass me all these things. Okay, pass me the different things. Okay, I'll just also write, I'll just enhance this figure, plt dot figure, and then fix size, fig size equals to 6 comma 6. So we'll have okay, fig typo, we'll have a bigger plot. Okay, 6 comma 6, I just have to write this. Okay, 6 comma 6, so this is my plot. And as you can see, the most correlated plot is around 448, highest correlation. Okay, the anode just gave me the correlation on the top of it. Okay, so this is the correlation matrix. All of are equally all of us are correlated, not that much, but together they'll make a good match. Then we'll just plot a pair plot now. Okay, one data missing. Oh, okay, sorry, I have to find the data. So I've given the data frame and the basis of quality. So now what it will give, it will give me the distribution based on quality. It will also take some time, because the pair plot computes a lot of basically the calculation, so it takes a few time. Okay, so now the last thing we have already done in the data analysis, that the value counts. Okay, what is the quality, or what are the different types of ranges of quality, and at least we have plotted, at last we have plotted a histogram for it. So this was the old data analysis part. There's a little, we had a brief of what are different variables and the correlation between them, how they are related with pH. Let's just wait for this pair plot. It will get executed in a few moments. So this was our data analysis. Now in the next section we'll be doing some data pre-processing, then finding out or doing the prediction using two methods. Okay, so I have already told you that we'll be following two methods. One is the basically the label prediction, and one is the classification. So it may be, now the figure is being plotted, it should be any minute now. So it will show me the different distributions of the plot. Okay, the pair plot will show me the different distributions, so that's why it is taking a longer time. It also depends on your machine. Also, I'm doing this in Jupyter Notebook. You can also do this in Google Colab. Okay, this is the basically the hue, and you see that one two different quality parts are there, and these are the different scatter plots and line plots for all this. You can have a look at this and study the whole data. You can have a look at whole the data, you will get all these things. Okay, so now in the next section we'll be doing the data pre-processing, or basically we'll be building a models in two different ways. Hello all and welcome to the next section of our project. So now in the previous section we have done the data analysis part. So now let us move to data pre-processing. There's not much to process in this. So the only thing is we'll be doing this in the first method, like using prediction using k nearest neighbor. Okay. So now let us do very quickly. First we'll be distributing our labels into independent. These are my independent variables and this is my dependent dependent variable. Okay, let us quickly split them. We're using train test split. I'm taking the split side, let's say do 20. Okay, random state, let's say give it 42, shuffle is equals to true. The data will get split. Now I'll just scale my data. So as you can see, if I'll just plot df sns sort this plot, and I'll just give df, I'll just get the distribution. The distribution will be sort of very much uneven. Okay, because these are not in the same scale. So for that what I'm doing, I'm scaling my data to bring out to the same scale. What standard scale I will do, it is scale them on the basis of their mean. Okay, it will take the mean. As you can see, the scale is not very good. It is very unevenly scaled data. Some are going this and those. So we'll just scale the data. I'll just import scalar and then let us see the data sns.dis displot. Let us see the train data. It should be good. Okay, so now as you can see how data is very good, data is perfectly distributed. This is the power of distribution. Oh, okay, one last thing we should do is we should check the shape of our data set after training and testing. It is 1279 and let us see the test shape. It's 320. Okay, good. It's a very small data set. The very first thing is we'll be using k nearest neighbor. So I'm just importing it. I'm just giving it to the 7. Okay, I'm taking the neighbor 7. You can actually see different neighbors, create a for loop and see different neighbors, so you can get the idea with the accuracy that okay, which is the best. Okay, I'll just predict it. These are the predictions and I'll just plot the confusion matrix and the accuracy. So the accuracy is 58.75, not that good. These are the different predictions. If you want to see the predictions and if you want to see the test, so this is the white test and these are the predictions. Okay, so now if you'll just basically the distribution or distribution part, we can actually cannot plot a distribution plot between this because this is a numerical value. Accuracy is not that good, you see 58.75, but we have not done anything. We can also do, what we can do is we can run a hyperparameter tuning on this. We can see, let us see this with a neighbor of 5. Okay, 7 is actually very low. See if we have something for accuracy. Okay, 55. Okay, actually decreased. Let us see for different neighbors. Okay, let us see 2. Accuracy is getting decreased by decreasing the neighbors. Okay, let us see 6. 57.18. Let us check for neighbors 10. Okay, 59.6. Okay, accuracy is getting increased for this level, but it may lead to getting overfitting of the model. Okay, the accuracy is still got decreased. Okay, so I'll just stick to, I think 9 is the best. 58.0. Okay, 9 is the perfect solution for this, I think. But this is a very rough figure. You can actually plot a graph and all of those things. I'm not doing that here. It was just to give you an idea. This was the first method. You get the idea. Okay, what I did, I had certain labels. So these are the label I'll show you. These are the different labels. Okay, 3, 4, 5, 6, 7, 8, in which 5, 6, 7 was the abundant. So I actually predicted the same, which wine belongs to the which quality. Okay, so now this is one method. I have another method to perform, so that I'll take you to the next section and we'll see that what is that next method. Hello all and welcome to the final section of this project. So now let us have a brief summary of what we have done till now. The very first thing we did was we imported the libraries. Okay, these were the different libraries. Then we read the data set. We did some data analysis and we created some figures, histograms, scatter plots, box plots. We did some of the things. Okay, pair plots. Then what we did is we processed the data and we scaled the data using standard scaler. Then what we did is we use the approach of predicting. Okay, we had the label, we directly predict the label using k nearest neighbor. Okay, knn, we directly predicted the labels. Okay, so now I have a new method. In this method, what we'll be doing, we'll be setting a benchmark. In this, I'm saying, in which we'll be classified the wine is good or bad. So we'll create a column which will state that if a wine quality is greater than 5, then it is a good quality wine, else it is not. So I'm just saying y is equals to df quality is greater than 5. All these things it will be stated. Okay, now if wherever the quality is less than 5, it is false. Wherever the quality is greater than 5, it is true. Okay, if I'll just okay, let's see if value counts work in that or not. Value counts. Okay, yes. The true are around 855 and false are around 724. So this is a pretty good balanced data set. Okay. Now previously we saw we had an imbalanced data set because only 3 of them were getting to a highest quality, then list 3 were not abundant. So this was unbalanced. That is why it led to not much good prediction. But here we have a balanced data set with true and false. So now what we are doing, this is our independent variables. Let us write them independent variables. So these are independent variable and the y is obviously my dependent variable. This is my dependent variable. Will classify if the wine is good or bad. I'll just split my data, just write it, splitting the data. Splitting the data into train test, 0.25 is the train. Again, transforming the data using the same standard scaler. Okay, scale test. I'll just see the shape x train shape 1199. Okay, good. And the test shape should be same. Actually, I just used a little bit different tip. 400. Earlier I used 20. Here I have used 25. So let's see, we'll just perform the classification. I'm importing svc, import svc classifier. svc c is equals to 1 kernel. I'm using rbf. The different kernels, we have linear kernel, sigmoid kernel, rbf kernel. We have degree tree, gamma. These are basically a certain amount of parameters, hyperparameters, which I have obtained from net to see which works better. What you can do, what I can do, I can also perform the hyper tuning. Okay, I can also perform the hyper tuning to find out these parameters. Okay, so you can do that also. So I'll just predict it. Now in this plot a confusion matrix. So 45, 55 and accuracy is 75. Not bad. Earlier we had an accuracy of what, 58 or almost 60, and we have an increase of 75. Okay, this is a very good thing, or this is a very good approach. Like, okay, as you can see the difference between the approaches, the last thing we have to do is we'll just plot a confusion matrix. Okay, so this is a confusion matrix in the true positive, true negatives. Okay, So this is a very simple code. I've just written a for loop for two to print them and then the different labels. Okay. Now as you can see the difference between the approaches. The first approach we use the label sorry, in that we obtain an accuracy of almost 60%, but in this in that we have an imbalanced data set, but in this we have actually a balanced data set, a good approach or a more thoughtful approach. So in that we have an accuracy of around 75%. Okay, this is the difference. So this notebook will be provided to you along with the data set. So practice this code, use different models, hypertune these models on your own, or use your brain, hypertune it, and you can also surely, I'm sure that you can get much better results. So I hope you enjoy with this. Thank you.